there. Okay, so what I'm going to do today is I'm going to go through Module 6. And let me share my screen, and I can show you where we are. Okay, so we did this multiplying polynomials last class, and it used to have these things were part of module 5, because I think these were separate. These were part of that chapter 10 that we were working in, but I don't think they are anymore. So I moved them out to a different module just to be a little more clear. And so this is module 6, where today I'm going to start doing this sort of equation solving review, which is most of chapter 8. And then next week we'll do a review of order of operations, and then next week will be mostly review, where people can get caught up with homework, or if they want to go over stuff for particular sections of what we've done, if they're going to take the final. The other thing I did, I don't have it written up yet. This is for math, for MTTH, but they're the same. The Canvas shells are the same between the two courses. So so there's an announcement in Canvas, and I'm not going to read it. You can go through and read it for yourself, unless you have access to Canvas, which would be a problem. But so this talks about what we discussed yesterday or the day before, where we'll have a final exam for this class, which is optional. And it's optional in the sense that I'm going to give you two different options for how you want to be graded in the course. And the first will be grading as it describes in the syllabus, where you just graded on the cumulative score between your, or average score between your weekly assignments and quizzes. So if you've done all the assignments and done all the quizzes and want to be graded that way, you still have that option. The other option would be if you just wanted to take one exam at the end of the course. So you'd have this single final exam, which would be 40 multiple choice and true-false questions, and it'll be delivered on Canvas. And so it's either or, it's one or the other, and you can decide which one you want. And so if you don't want to take the final, you don't have to, but you would have to do all the homework and then take the 6 quizzes. There'll be 6 quizzes by the end of the quarter, and I'll go through those in just a minute. So so you could do that. You could do option 1, or you could take this final, which will be 40 questions. They'll be drawn sort of from all of the 6 sections we've done. So you could figure there might be 6 to 7 questions from each section on the final. There'll be multiple choice, true, false, a mix, and then if you do this option 2, where the grade on your final would be your grade for the course, so you wouldn't have to do any of the homework. You just have to take the final. But I am going to require that for this to count, for option 2 to count, you have to get better than 80%, meaning you have to get 32 questions out of the 40 questions answered correctly. Okay. And so the other option would be for all the homework and everything, I will require it by midnight on June 5th, but the final has to be in by noon, just because. So, because I want to have a chance to go over it, and if you don't pass it, I want to be able to tell you that, hey, look, if you push hard, maybe you can get your homework done and still pass the course. So the final has to be done by June 5th at noon, 11:59 a.m. That's a Friday, if it makes a difference. Or you can do the homework. So it's one or the other. It's laid out here. I think it's relatively straightforward. The grading for option 1, the homework will be as described in the syllabus. There's a mix between the homework and the assignments. And I think I still haven't corrected Canvas, but 60% of your grade is determined by the homework and 40% of your grade is determined by the quizzes. So as the assignments go and the quizzes go, I've missed a couple of weeks of getting assignments out, because I think that people weren't getting them done anyway. So we'll have one more in-class assignment on this equation solving review, which I'll get out next week. There's the final one here, which is assignment 20, which is multiplying polynomials. So there'll be 21 assignments in total. And they'll be, I guess it was 40% of your grade. It says 25% here, but I haven't changed that yet. So it's going to be 40% of your grade. There was supposed to be 9 quizzes. Clearly, we don't have time to take 5 more quizzes. So I'm in the process of writing this quiz 5 and 6, which will combine these two things. 5, 6, and 7 will cover this material. So graphing equations, and then it will do the sort of geometry did, and then measurement application. So 5, 6, and 7. And then so that will be quiz 5, and then there'll be quiz 6, which will be on all the polynomial stuff. So this part of quiz 7, which would be on adding and subtracting polynomials, will be blended into quiz 8, along with a little bit on solving equations. So there'll be 2 more quizzes remaining for the course, and then there'll be 1 more assignment. So you can sort of track your project progress. And instead of 75-25, it's going to be 60% from the quizzes and then 40% from the homework. So it should be relatively straightforward in terms of what's left to do. And so this will, these will be available. I'll get the quiz done maybe today, and then I'll put it up, and then you can work on it whenever, if that's what you want to do. And this quiz, the final quiz I'll get up by the beginning of next week. I'll get that written by the beginning of next week. So any questions on what's left in terms of homework or anything, or the structure of the course from here on out?
Yeah.
Yeah.
You can see what our grade is, right?
Yes, I can.
Okay. Because I'm
Yeah.
just looking through the assignments that I haven't done yet.
Okay.
And yeah, it's like what, 2 from module 1, only 1 assignment missing from module 2, and 2 assignments from module. Which module is this?
Yeah, let me stop sharing my screen, because I don't, if I look at grades, you'll see everybody else's. So let me stop sharing my screen, and I can take a look at what your grades are. So here we go. I can look at what's done. Hang on. Yeah, so you're pretty much caught up. Oh shoot, this thing is, it's not what I want. Sorry, I'm fighting with my browser. Just a second here. There we go. All right, so let me move over. Yeah, you've got 6.3 isn't done. So you got 1, 2, 3. So you're only missing 3 assignments. So you may not want to do the option of 1 exam, right? And you've done pretty well on most of these quizzes and everything. So for that might not be a good option for you, right? So it's sort of that, but there are several people that are in the situation where they're really behind in the homework, and for them, I thought maybe 1 final might be a useful thing. So and for other people that are kind of monitoring the course from afar that haven't done a lot of the homework. So in your case, you might not want to take the final, right? You could just blow it off, right? So it's like I say, it's completely optional, and if you don't take it, then I'll know to grade you based on your homework and your quizzes, right?
All right.
So I wouldn't, and if you choose not to take it, it's really not it wouldn't. I mean, it really is an optional thing for people that got behind in the homework. So it's not a requirement. Okay. And frankly, if you did all the homework, the final quiz, the final exam would be a snap for you, right? You'd just be able to cruise through it because you pretty much have done all the homework, and so it wouldn't be a shock to you to see. You wouldn't see questions there that you hadn't touched before. So I think you're in pretty good shape because of these assignments that are left. There's only a couple of them that you haven't done before, and one of them that you and two that you haven't done. 2 out of the 3 or 4 that you haven't done because they just got posted to Canvas. So I think you're in pretty good shape.
So after this is Math 87, right?
Yes.
After this, would I go to like the next highest one? Because for when I registered for my classes, I selected Math 92.
Yes.
Just because, okay.
Yeah, and so that would be the track, and then the idea is you take Math 92 and then Math 98, and then after Math 98 you are ready for the 100 level math courses.
Okay.
Right, and in some cases, if you did really well in Math 92, they might say, look, you could take Math 98 concurrently with higher level math courses. Or I've heard, don't quote me on this, but I've heard people just moving directly from Math 92 into the 100 level stuff. So, do you know who you signed up for Math 92? Because I know I teach that next quarter.
Yeah, I selected you. It was you and another teacher, so I just selected you.
Sure. Okay. Yeah. So that'll be another one of these math courses I've never taught before. So that'll be sort of a new experience for me next quarter. I've taught Math 98 a few times, but Math 92 is not one that I've done before. So, but I think that we'll use another online text, open source text, like we did this quarter. It's I forget the name of the guy's, Tyler Wallace. So the course will have much the same structure it does now, where because it's online, the lessons will be done online and everything, but it will be a true online course. I mean, they're all being offered online, not as this sort of pseudo online thing. So I think that the way it gets delivered will be a little bit differently. Like we can structure the meeting times to be more flexible so that you don't have to come during the middle of the day, that you could come at an evening if it's more convenient, or we can schedule it when the majority of the class can be there, right?
Okay.
Okay. So that's how it'll work next quarter. It didn't work that way this quarter because everybody was sort of delusionally thinking we'd be back, in a classroom by May.
Yeah.
Nobody was quite thinking about what was really going to happen. So if we'd been smart about it, we would have realized that there was no way to be back in the class. Okay, let me turn this off and I can start sharing my. Okay. All right. Let's see, share screen. All right, so that gets that sort of procedural stuff out of the way, and I think that we can go through now and look back at these solving equations. And come on. Is that big enough? Can you read the text over there?
Yeah, I can read it.
Okay, cool. All right. Oops, that's not what I meant to do. All right. So I'm going to briefly go through the different sections of chapter 8, which is all about solving linear equations, right? So solving linear equations, and what we mean by that is a linear equation would be something of the form over here where we had 3x plus 5 equals 2, right? And so we want to find out to solve that equation, what we mean is finding the value of x that makes this equation true. And it seems like it's really mystifying and everything, but really remember when we talk about this, and I talk about this in the book, that this x here is just a placeholder for a number. And so when people see it, you don't have to think that it is something mysterious. It's just a placeholder for a number. And we use a letter instead of a number because we don't know what that number is yet. It's an unknown, right? And so if we wrote something like this, if I said blank plus 3 equals 10, right? I mean, it's relatively straightforward for you to think, okay, well, I have to fill in that blank with a number that makes that statement true, right? And the answer there is obvious. Well, that's 7. 7 plus 3 equals 10, right? So there's really no difference between writing this, blank plus 3 equals 10, and x plus 3 equals 10, right? And so the mental processes you use to solve this in your head are identical to something like this: x plus 3 equals 10, right? That you sort of, if you do it like I do it in my head, I sort of do it by trial and error, figuring out what do I fill in this blank to make this equal to 10? Well, I could put 8 in there. 8 plus 3 is 11. That's not right. I could put 6 in here. 6 plus 3, that's 9. That's not right. So it must be 7. 7 plus 3 equals 10. Right, right? I mean, so you sort of do that kind of math in your head. It's almost trial and error. But when things get complicated, there's actually a systematic way you can attack these problems, and that's what solving these equations is all about. Is developing the systematic way to go through it. So, and this is touching on algebra. So, and algebra, as I've said before, is all about symbolic math and manipulating symbols to solve equations and find answers. So in algebra, one of the key concepts is balance, or treating everything the same. So the key concept in algebra is you can do the same thing to both sides of an equation and it remains unchanged. So for example, we could say to ourselves, okay, well, with this particular simple equation, x plus 3 equals 10, I could do things to this equation like x plus 3, and then I could subtract both from 3 from both sides, 10 minus 3, right? I've done the same thing to both sides of the equation. I subtracted 3 from the left side and I subtracted 3 from the right side, right? Well, when I do that, this x plus 3 minus 3, this just becomes x, and this equals x equals 10 minus 3, which is equal to 7, right? So this is a systematic way to solve that equation by isolating x on the left-hand side, and then everything else on the right-hand side is just arithmetic to be able that we can solve to find the value that makes this equation true, right? So that's what we're going to be doing here with this section 8 or chapter 8, and we probably won't get through all of it today, but we're going to sort of wander through it and talk about different ways to do it, right? So the first thing they do is they want to figure is they ask us to do this example here, and we want to determine whether y equals 3 is a solution for 4y plus 3 equals 8y, right? So looking over here, as we talk about this, where we wanted to find the value of x that made that equation true, right? So here we want to find out if we've given this value of y equals 3/4, and now we want to find out if that is a solution, 4y plus 3 equals 8y, right? So what we do is we substitute in this value for y into each term here where we see y. So this becomes 4, and now we're going to multiply it by 3/4, because that's what y is equal to, and then we add 3, and then we want to see if it's equal to 8 times 3/4, right? Okay. So in this case, we could just do this multiplication. So this is 4 this 4 is going to cancel this 4. So this is just going to be 3, right? Because this 4 will cancel that 4. The 4 in the numerator, 4 in the denominator cancel. We're just left with 3 plus 3, right? And that's going to be equal to 8 times 3 in the numerator divided by 4. And that's going to be equal to 24 divided by 4. Well, 24 divided by 4 is equal to 6. Does 3 plus 3 equal 6? Yes. So 3/4 is a solution to this equation. And that's how you solve these problems if you're given something, given a number and want to find if it's a solution to an equation, right? So let's look at this one. Is y equals 2/3 a solution to the equation 9y plus 2 equals 6y? So we have 9y plus 2 equals 6 times y, right? And we have a trial solution for y equals 2/3, right? So now we can take our equation and then we can take 2/3 and substitute in here and here. Fair enough? Is that simple? Okay. So that now this is going to be equal to 9 times 2 over 3 plus 2. And this is going to be equal to 6 times 2 over 3, right? So this becomes 18 over 3 plus 2 equals 12 over 3, right? Okay. Did I do that right? Yeah. Okay. So what's 18 divided by 3? Well, it's 6. 6 plus 2. What's 12 divided by 3? It's 4. Does 6 plus 2 equals 4? No. So y equals 2/3 is not a solution to that equation. Okay. And it's relatively straightforward to if you're given a value for the variable, to plug it into equation and determine whether or not it's a solution. Okay, so that's a relatively straightforward thing to do. And so then they talk about this subtraction and addition properties of equality, right? So this is what I was talking before here. Let's try it this way. Okay. So what they talk about here, why can't I get that to split the page? Oh, I know why, because I stupidly did this. Okay, there we go. Sorry about that. Okay, so if A, B, and C are real numbers and A equals B, then this is this sort of, this is what I was talking about. Then A minus C equals B minus C. You can take the same, you can do the same thing to both sides, right? And it's also true if A equals B, then the A, B, and C are real, then A plus C equals B plus C. So you could do the same thing to both sides of the equation and the equation remains unchanged. Okay. So, and they've got a visualization here where they had envelopes and counters, or they have masses, all right? So that if you have equal masses on both sides of a scale and they're balanced, and we add the same mass to the same side of the scale, then they remain balanced, right? But if we only add mass to one side of the scale, then they're not balanced. And by the same token, if say we cut off here, if we had the same mass and we cut off half of this mass and the half of that mass, subtracted half the mass off both sides, then they would remain the same, right? Okay, so So now we're going to go back and look at using these properties to solve simple equations, right? So let's look at this example here. So they have x plus 11 equals -3, okay? So what value of x makes this whole equation true? Well, we can figure that out by using this balancing property of subtraction. X plus 11 minus 11 equals -3 minus 11. I took the same amount off of both sides of the equation, right? So now this becomes x plus 11 minus 11 is just x. So x is equal to -3 minus 11 is -14. Okay. So x is equal to -14, which is what they get. X equals -14. And you can substitute that back in to make sure it's true. So I'm just going to do another one of these simple examples. X plus 9 equals -7. Whoops. That's really messed up. X plus 9 equals -7, right? So we have x plus 9 minus 9 equals -7 minus 9, right? X equals -16. Okay. If your equation just looks like this, it's relatively straightforward to manipulate them. Here they've got the example, m plus 4 equals 5. So m plus 4 minus 4 equals -5 minus 4. This should be minus a minus 4, right? M minus. Oh, I'm sorry. M plus 4. Yeah, right. M plus 4. This isn't right. They've screwed this example up. Oh, okay. This is what they've done. Okay. M minus 4 minus 5. So they've got a typo here. This should be m minus 4 equals -5. And in that case, right, I'm sorry. Okay, I see what they've done now. So this should say m minus 4 here. And then what they've done is they add 4 to both sides. So they add 4 here, and this should be, let me write it out over here because this is really messed up. It's really confusing. Sorry about this. So the original equation is m minus 4 equals -5. So m minus 4 equals -5. And now to solve this one, we want to use the additive property. So m minus 4, and we're going to add 4 to both sides, equals -5 plus 4. Right? See the difference here of what they've done? They got this all messed up, right? But this is correct, and they get the correct answer here, even though they didn't do this part right. So m minus 4 plus 4 equals -5 plus 4, right? So m minus 4 plus 4 is m, and -5 plus 4 is -1. And that makes this original equation true. -1 minus 4 equals -5. Okay, -5 equals -5. So again, they've got this part wrong here. This is completely, the solution to m minus 4 equals -5, so -1, right? Okay, so, and you can work with fractions, right? And I'm not going to belabor this because it's just going to, get really confusing here. But you can add this. So n minus 3 over 8, n minus 3/8 equals 1/2. And so you add 3/8 to both sides, and then you have to simplify that fraction, right? And then you get n is equal to 7/8. Okay. So you can work with fractions just as well as you can with whole numbers. You can work with decimals. You just add the decimals. So it's really relatively straightforward. Now they move into a little more complicated example, equations that need to be simplified. And they've got this example here where we've got 3x minus 7 minus 2x minus 4 equals 1, right? And so what you do then is just like when we work with polynomials, is you combine like terms. So you combine the 3x and the minus 2x, and you'll just get x. And you combine the -7 and the -4. So -7 minus 4 is -11. And then you have x minus 11 equals 1. And then you use the additive power. So you add 11 to both sides, and you get x equals 12. And then they substitute back in to show that it actually is a solution. So these work the same way, where you have 6z minus 5z. So you come out with z, and then you have 5 minus 4 is 1. So z plus 1 equals 3. And then you would move the 1 over to the other side, and you get z equals 2. And if we check that, we would say that's 12 plus 5 is 17, minus 10 minus 4 is 3. So it works out, okay? So, and here, simplifying this, they just have to do, you have to do the distribution first, right? So this is your starting equation. You distribute through the 3, so you get 3n minus 12 minus 2n equals -1. So 3n minus 2n is n minus 12 is 3. So you add 12 to both sides, and n is 9. Okay. So let's see, what is the next step they wanted to do? Oh, they want to do word problems. I think let's see. Okay, so let's look at a word problem here. This is a relatively simple word problem. So Shayla paid $24,575 for her new car. This was $875 less than the sticker price. What was the sticker price of the car? Okay, so we're asked to find the sticker price of the car. So we assign a variable. So let's let S equal the sticker price of the car. And the sentence $24,575 is $875 less than the sticker price. So that means $24,575 is equal to S minus $875, right? And now we use the equality property of addition, so we can add 875 to both sides. And what you get is that the sticker price is equal to 24,575 plus 875, right? So somehow they didn't do this addition right. Yeah, okay, so they didn't do the addition, but they've got it right here, 25,450, which is 24,575 plus 875. So they didn't do the addition right, okay. So let's do one more of these as an example, okay. So Eddie paid $19,875 for his new car. This was $1,025 less than the sticker price. So we could say that S minus 1025 is equal to 19,875, right? So we can do S minus 1025 plus 1025 is equal to 19,875 plus 1025, right? So S is equal to 19,875 plus 1025, which is equal to 20,900, 2,900, right? I think that's right. Yeah, 20,900. Okay. So the key with all of these is just remembering how to set the problem up. Okay, so that's section 8.1. And those are relatively simple. Okay, so the division and equality, the division the division and multiplication properties of equality, right? Doing the same thing to both sides of the equation extends to division and multiplication. So if I have A equals B, and that's true in both the real numbers, and then I have a number C, which is also the real number, then A times C is equal to B times C, right? Similarly, A divided by C is equal to B divided by C, provided C is non-zero. If C is 0, that's not true, right? This part, because whenever you divide by 0, the answer is undefined. So this isn't true, and that's only true for C not equal to 0. Not equal to 0, right? Okay. And I'm sure they mentioned that. Yeah, for C not equal to 0, if A equals B, then A divided by C equals B divided by C. Okay. So you can use that property to solve an equation that looks like this. 4 times x equals negative 28, right? So you have 4x equals negative 28, right? So you could write that as now 4x divided by 4 is equal to negative 28 divided by 4, right? Well, 4x divided by 4 is just equal to x, and then negative 27 divided by 4 is equal to negative 7. So x equals negative 7, right? So you can use this division property of equality to divide both sides by 4, just like they've done here in the book. You get x equals negative 7. And you can go back in and check it, right? So we could do the same thing with this one, where we have, let me take out all these coefficients. Whoop. And here we had 3y. So we got 3y is equal to minus 48, negative 48. So we have 3y over 3 divided through by 48, negative 48 divided by 3. So this is y is equal to negative 16, right? Because 3 times 16 is 48. So y is equal to negative 16. So if you have this equation here, working with negative signs, if you have negative r is equal to 2, you can remember that you can always write that as negative 1 times positive r is equal to 2, right? And then once you've done that, you can write this as negative 1 times, oops, that's not what I meant to do. Negative 1 times r divided by negative 1. That's 2 up here. So sorry, 2 is equal to 2 divided by negative 1, right? So negative 1 divided by negative 1 is positive 1. So this is just now r. And 2 divided by negative 1 is negative 2. So r equals negative 2, right? So basically, but you're dividing through by negative 1, and you're moving the negative side to the other part of the other side of the equation, right? You could just as easily think about this in the same way as saying, instead of dividing through, you could say, well, this is negative 1 times r equals 2, but I could also write this now as negative 1 times negative 1 times r is equal to negative 1 times 2, right? Equally valid to do it this way. Well, what's negative 1 times negative 1? positive 1. So we get the same thing. And negative 1 times positive 2 is negative 2. So r equals negative 2. So when you have to move the negative sign over to the other side of the equation, you could think of it as dividing through by negative 1, or you could think of it as multiplying through by negative 1. And it doesn't matter, whichever is easiest for you to think of conceptually. And if it confuses you to think of it as in terms of one or the other, then don't think of it that way. Just think of it as one of them. Okay. So let's see. Okay. Oh, okay. So let's look at this, guys. So what they've got is they've got 2/3 x equals 18. Okay. So what do we want to do in this case? Well, in this case, we probably have 2 steps. One is we want to get rid of this 2/3 here, right? So we can figure out what x is. And so we could think of this as saying, okay, well, let's multiply this right? So we could think of this as saying, okay, well, let's, we know we have to get rid of the 2, so we can say, well, let's divide through by 2 times 3, both sides of the equation, and this becomes 18 divided by 2, right? Because we're dividing through by 2. And now we could say, well, let's multiply through by 3 times 3 times 3 on both sides of the equations, right? And so now we have 2 times 3 here, and we have 2 times 3 here, so that goes away. And we're just left with this, right? Which would be equal to 9 times 3 is equal to 27, right? Because 18 divided by 2 is 9, 9 times 3 is 27. So x is 27. Okay. So if you have a fraction, it doesn't matter. You can do the same thing. It's just sort of a 2-step process here, as I've diagrammed here, right? And they'll do the same thing, right? They just multiply by 3/2. And so this is the same thing they did in the previous chapter where they solved the equations that need to be simplified. I mean, they combined like terms before they simplified an equation, right? Then let's see. All right, where are we now? All right. So now we're going to move on to variables with variables and constants on both sides. So solving things like this, 4x plus 6 equals negative 14. And solving something like this is what we call a 2-step problem. And it's called a 2-step problem because there are 2 steps to solving it, okay? So let's look at that in that context of that particular example, and then we'll look how the book does it. So 4x plus 6 equals negative 14, okay? So what are the 2 steps and why is it called a 2-step? Well, first thing you want to do is you need to get that 6 off of the right-hand side of the equation into the left-hand side of the equation. How do you do that? You subtract 6 from both sides. So 4x plus 6 minus 6 equals minus 14 minus 6, which is equal to minus 20, right? So we can rewrite this as 4x equals minus 20. What do we do next? We have to divide through by 4, right? Both sides by 4. Oh, that was bad. That was a dumb way to do it. Sorry. So 4 becomes negative 20 divided by 4. So this is now x equals negative 5. So it's called a two-step method because here's step 1, subtracting 6 from both sides. Here's step 2, dividing through both sides by 4. So the two-step method, step 1, step 2. Okay. All right, so we can go through and we'll see here they do exact same thing. They subtract 6 from both sides, they divide through by 4, and they get x equals negative 5. So solve an equation with a variable on both sides. Well, this is just a different method of the two-step method. So how would you do that? Well, to solve an equation, you get all the variables, everything that has a variable on one side of the equation. How would you do that? You would say, okay, well, so look at this example, 5x equals 4x plus 7. So we have 5x equals 4x plus 7. And just like in the book, you can move the x's away from the right-hand side of the equation by subtracting 4x from both sides of the equations. 7, right? So it goes away from here, and here we have 5x minus 4x. We're just left with x equals 7. All right. Right. 7. Okay. I think let's move a little bit forward. So what I'll do is I'll go through some examples in the back of this section. I think that's got to be the, oh, okay. So they do more and more complicated examples. So we'll do some of these here. I see now. Okay, so whenever you have a linear equation with just, with a bunch of x's, simple variables of x, it can look complicated, but it will always break down into a series of relatively straightforward steps. So let's look at this. 4 times x minus 2 plus 5 equals negative 3, okay? So the first step would be use the distributive property to distribute through here. So we get 4x minus 8, 4 times x times 4 times minus 2, plus 5 equals minus 3. So, so now we can combine minus 8 and 5 to get minus 3. So we're going to get 4x minus 3 equals minus 3, right? So now we can add 3 to both sides. So we get 4x minus 3 plus 3 equals minus 3 plus 3. I'm sorry, yeah, plus 3, right? So on both sides, minus 3 plus 3 cancels out. So we have 4x equals 0. And then from that, we know that x has to be equal to 0, right? So we should come out with the same thing. Yep, x is equal to 0. And they actually went through and did this division. We don't really have to do that because we know that the only thing that can make that equation true is 0, right? All right. I think maybe I'm going to, what is 8.4? What's 8.4? Yeah, I think I'm going to stop there. And what I'm going to do is I'll assign some problems out of this section. And then maybe tomorrow we can come through and do the ones I've assigned. And so maybe, and I think that'll be it for today in terms of the lessons, so that we don't have to just work some problems blindly out of these sections. We'll do them. I'll assign, like I've done 10 problems, and we can work through them so that you can have some experience solving these two-step equations. Does that sound okay to you, Solomon?
Yeah.
Okay. All right. So because I have a Zoom meeting at 1:30 that I have to go to, so I need to get ready for that too, which is bad, but it's the world we live in now. So do you have any questions over that? Was that relatively straightforward? It was kind of a scattershot approach to the section, but I think based on what we've been doing over the quarter, this should be not completely unfamiliar to you.
Yeah, at first there was a little, one of the examples kind of put me off guard a little bit, but
Which
yeah,
one was
it's
it? The
9y plus 2 equals 6y.
9y. Oh, yeah, that,
That
because
one?
you had y on both sides of the equation.
Yeah.
Yeah, just, yeah, and just remember that when you're doing something like that, that if you see an equation that has x's or y's or whatever, or p's, right, on both sides of the equation, so you have 5t minus 3 equals 2t plus 2, right? I mean, the thing to remember about that is that you always want to get it so that your equation has all of your variables, everything that has a variable in it on one side, and everything that's just a number on the other side, right? So when you're trying to solve this, what you want to do is you want to move these t's here over to the other side of the equation. And since you know that these are both real numbers, or you can assume that they're both real numbers, you can treat these as one thing, right? So that in your mind you think, okay, well, 2 times t, that's just a different way of writing a particular number. So what I can do is I can rewrite this as 5t minus 3, and then I can say I'm going to subtract minus 2t from both sides of the equation, and that's equal to 2t minus 2t plus 2. See, what I've done here is I've said, well, this is just a number, so I can subtract any real number from both sides of the equation, and it doesn't change it. So I'm going to subtract minus 2t from here, and I'm going to subtract 2t from here, and I'm going to subtract 2t from here. And that changes this equation now into 3t minus 3 is equal to 2, right? Because the 2t went away from here, and I'm just left with 2, right? So all you're doing is you're combining t's onto one side of the equation. And so now you would be left with saying, okay, well, now I'm going to add 3 to both sides of the equation. Minus 3 plus 3 is equal to 2 plus 3, right? So that 3t is equal to 5. And now I would use the division. So I would have 3t divided by 3 is equal to 5 divided by 3, right? Whoops. So that t is equal to 5 divided by 3. Okay. So when you see something like this up here, just remember that the job is to get all the t's on one side of the equation, or if this were written with r's, you want to get all of the r's on one side of the equation, or if it's x's, right? Doesn't matter what the variable is, you want to get them all on one side of the equation. Okay? And you can do that because you can assume that they're both real numbers, or that both 2 and t, you can assume t is a real number, so 2 times a real number is still a real number, so that you can treat this as one thing, subtract it, and move it to the other side. Or if you wanted to, you could subtract 5x from both sides of the equation and move it over to the other side that way, right? So doesn't matter. So it can be a little confusing, but it's all the same thing. It's just recognizing that this is a number and I can move it to either side of the equation that I want to, right? So, and in algebra, when you go farther, you'll recognize that you can treat things like this, where you had, say, 5 over x plus 2 is equal to 3. I don't know if this will work out to anything sensible. You can treat this much the same way by saying, oh, hey, look, x is just a number. So I could multiply through this whole equation by x. And let me just copy it down. So I could multiply this by x, this by x, and this by x, right? And now the x goes away. And since I multiplied both sides of this equation by the same number, it's all going to go away, so that, you know, this x's go away, and I'm left with 5 plus 2x. 5 plus 2x is equal to 3x, right? And this I can solve the same way I did before by moving things around, right? So the key in algebra is recognizing that this variable is just a number, and you can do anything to it that you could do with any number. So when you see that, don't think it's something mysterious or complicated, because it's not. It's just a substitute for a number. It just means any number you want could put in there, right? Well, as long as it's, in this case, as long as it's not 0, right? So in this one, it turns out to have a relatively convenient solution of x equals 5. X equals 5. And we can see that's true by plugging that back in here. So 5 divided by 5 is 1. 1 plus 2 is equal to 3, so 3 is equal to 3. Okay. Hopefully that makes sense. Hopefully that helped a little bit explaining that.
Yeah, it did.
Okay. All right. So I'm going to stop there for today, and we can, if you want to stop by tomorrow, I will put up a few, 10 questions into Canvas on for this assignment, and that way you can work on it. So that would be, come on. Oh, it's because I've got video going. It's always slow. Yeah. So that would be this guy, equation solving review, and I think that'll be the last assignment for this week, for the quarter. We won't have any more. And then next week we'll just do these sort of review things. So.
Okay.
Okay.
All right.
All right. All right. Well, have a good day.
You too.
Right. I'll talk to you later.
See ya.
Okay. Bye.